a lot of information coming in. So what we're going to find, we're going to have some association areas. We're going to need those basal nuclei, those areas of the nerve cell bodies embedded in the white matter, okay? We're going to have the information from the brainstem and the cerebellum. This is the stuff that you're unaware of, but the brain is constantly paying attention to, because it takes that with the stuff that you are aware of to make something make sense. Okay? How do we know what happens, the function of this? Because of this right here. Anybody ever had to have one? An electroencephalogram? Anybody ever had to have one? Known anybody that ever had to have one? Patients? Okay. What do they do? Do you know? Are you involved with any of that? Or do the techs come in and do? Okay. So the EEG, they come in and they have all these little electrodes that they place around your head, okay? And then they hook it up to a machine. Now, why is it that they can measure the electricity of these cells?
Is it from the
Nate?
Is it from the nervous system?
What parts? Alex, did you have anything?
Probably the electrical impulses are conducted through the skin, through the brain, to the skull and skin.
Well, we have the nervous system. We've got the electrical impulses. Emma? No, you didn't have.
Well, I just said it's because it's constant.
Yeah, it's because it is electrical, okay? And the nervous system is constantly, busy, okay? Those little electrodes, think of that term. That means they can pick up the impulses. And they're picking up the impulses of the electricity based upon the ions. You guys remember sodium, potassium, calcium, chlorine, okay? Everything that's involved in an action potential, okay? Now, they know, based on information that they've learned, that as they do this EEG, they usually have the patient do different tasks, okay? Like maybe just relax, maybe close their eyes, maybe read, maybe write. They do this because they know that there is a certain electrical wave that should be showing up based on that activity. EEGs are very helpful to neurologists because they can look at those results and, based on the activity, based on the awake level of the patient, they can look at it and determine if there's brain damage at that point. So EEGs, they're monitoring that electrical activity of those neurons. It helps these neurologists diagnose certain brain diseases, lots of things now. The actual EEG itself has increased in its ability to pick up stuff over the past probably 20 years. It's increased greatly. It can actually detect metabolic abnormalities. A metabolic abnormality of the brain means they would be checking for the stuff such as the potassium, the calcium, the sodium, chlorine. PET scans. Have you ever known anybody who had a PET scan? I want to do one, but you know, insurance just won't do one to do one, okay? Mainly because PET scans are the last test a doctor ever orders. Mainly because the test is very expensive and what it does, okay? Pretty definitive in its results, okay? It's pretty accurate. It actually uses radiated glucose. Now think about that in relationship to the brain tissue. Brain tissue, the only energy source, okay? The only, not energy, maybe I should say food source that this tissue can use is glucose. So if they can irradiate that glucose and trace it through the brain, they're getting to see areas of the brain that will either light up or not, meaning there could be brain damage. But they do PET scans other places too, okay? Because cancer, for example, like if they're doing PET scan, like maybe of the lungs or something like that, cancer is very hungry, okay? So cancer looks for food sources. So if they've got a glucose, that area lights up. That's usually indicative of cancer. Maybe showing how much it has spread or maybe how much it's shrunk, okay? But anyway, so metabolic abnormalities, brain tumors, trauma. I mean, the list is long for what this little simple test altogether can do. Not simple, but compared to other ones that can be done, it is a more simple test. And the biggest thing it shows us is our states of consciousness. Because this is what this area of the brain is dealing with. This area of the brain is looking at consciousness. We know that at certain activities that we do, a certain brain wave should be present. So we have them known as the 4 different types: alpha, beta, theta, and delta. And they know that if someone, for example, okay, let's say this right here, this wave, was showing up while they're trying to get that person to read or write or color a picture or something like that. If this wave is showing up at this point in time, that person's got brain damage. And they've got to try to figure out what it is. So in a normal EEG, as they would try to get the people to mimic these activities, okay, like maybe at rest, maybe being stimulated in some way, maybe trying to get them to be drowsy, blah, 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 they would know that this should show up. If one of them shows up at a time that it shouldn't, it's letting them know something is wrong. So these actually measure our states of consciousness. So then, what about when we are like asleep? I mean, oh, did I give that one to you guys? I didn't? Hold on. I need a copy of that one. I might not. Did y'all have the other one? The brain waves?
Yes.
You have the brain waves? Okay. All right. Let me go make these copies and I will be, oh man. Okay, so you have that, you have that. All right, let me go make these copies. I'll be right back.